This video is a review of functions. We talked a little bit about functions early in the year, but I want to go over some concepts because we're going to get heavily into functions now. First thing is some vocabulary. So you're going to need to have this in your notes. If you need to pause and write this down, then you can do that at any time. The domain of a function is the set of all the inputs, or the x values. Sometimes it's a list, sometimes it'll be something like all real numbers. Okay? The range is the set of all the outputs. So domain and range go together. Inputs, outputs, x's, y's. Okay? If you're given a table like this is the domain, 0, 2, 3, 6, because those are the listed x values. And I could write them like this instead of parentheses. The range would be 5, 7, 10, and 12. And I could write them in a set of parentheses like this, because that's all of the outputs of the function. This is the domain, this is the range. I got them from looking at the table. Okay? The definition of a relation is simply a set of inputs and outputs. It's just like a relationship. Okay? Somehow or other, these two are a relation. They have some sort of relationship. Now, a subset of relations, some relations, are also functions. But functions have a special requirement. They have to have no x values being repeated. So if I were to look at this, I would see that every individual x has its own y. No x values are repeating. Okay? So if you need to pause that and write that down, then go ahead and do that now. Here are a couple of examples of some relations that I set up. So you'll often see these with arrows pointing to which ordered pairs go together. So this -5 goes with this 4. This 2 goes with 6, 7 goes with 2, and 10 goes with 4. So when you see those arrows, that's a mapping. That's a mapping format. They're just showing you what goes together. This one is a function. All I need to do is look at the inputs, and I get no repeats. That's a function. Look at the second one. I look at here. Oops, I have a 2 here and I have a 2 here. That means these x values of 2 are both mapping to a different y value. That can't be. This one is not a function. Now if I were to graph these, I could kind of confirm it to myself. Here, I'm graphed each of the points and see how they're just individual random points. Over here, if I graph these points, I want you to notice this. See how I have 2 points on top of one another? That's these 2 points here. Because they share, the x's are both going to have a different y value. This is where the vertical line test comes in, which you probably used in Algebra 1. And that is, if I were to take a vertical line and move it across my graph, would I get more than one point in there at a time? If the answer is yes, it's not a function. This one, every point is individual. But look at this one. Boom. My vertical line will catch 2 points at the same time, so that's not a function. That's the vertical line test. So I want you to take a minute and look at these and decide whether these in fact are a function. Okay, take a look at number 1. We have an XY table here, input, output, and there are no repeating x's. Therefore, yes, it is a function. Now, you might be tempted over here to see that the y's are repeating. It doesn't matter. Y's are allowed to repeat. X's are not allowed to repeat. So whenever you're looking to see if something's a function, I want you to look at your x values. Okay? About this one. Vertical line test. Whoops, I have several points that are not going to pass the vertical line test. So the answer to that one is no, it's not a function. And the last one, just look at your x's. Oops, the 5's repeat. 5 goes with 4 and 5 goes with 8. So this is not a function. Okay? If you had any questions on that, you need to go back and review what is a function. Now let's look at function notation. Well, hold on a second. I just want to remind you that we have 3 representations when we talk about functions. You might see an equation, you might see a table, and you might see a graph. All 3 of those represent the same function. Okay, so any given function may have 3 representations. And sometimes some of them are going to be easier to deal with than others. Sometimes looking at a graph will tell you right away some information. Other times looking at an equation will be more helpful. So we'll get used to using all 3 representations so you can pick and choose what's more helpful. Now I want to talk about the notation. So before we've used y equals 3x plus 7. In function notation, we simply change that y out for an f of x. And this is pronounced f of x. Okay? It is not a multiplication symbol. In the past, we've used parentheses for multiplication. Not anymore for this. F of x means the function of x where I multiply x times 3 and add 7 to it. So this is telling you that there's a rule coming. This is the rule. So if I had f of x equals 3x plus 7, find f of 2, this is the same as if I gave you this equation and told you to plug in 2 for x. This is, this is simply another notation. So we're going to take this f of 2 and put it everywhere we have an x, we're going to put a 2. Okay? So we multiply and we get f of 2 equals 6 plus 7, f of 2 equals 13. Now, here's what some of you do here. You decide to try to divide both sides by 2 because you're thinking multiplication. This is not true. F of 2 equals 13 means when I plug 2 into that function rule, I get 13 out. In other words, the ordered pair 2 and 13 goes into this function. So stop when you get to here. Do not do anything with that f of 2 or f of 7 or anything else. Leave it alone. Only solve the right-hand side. And this is what it represents. When I put an x in and put a 2 in for x, I get a 13 out. This is the ordered pair that represents. We will practice several more of those in class tomorrow. Now, this is also something that we've primarily done before, but I want to look at it with a slightly different eye. These are our function families. We've done most of these equations already, and those that we haven't will be starting up pretty soon. But I want you to look at them in terms of the f of x. That's the only thing that's changed, is I've replaced y with f of x. So we have a linear, we know what that looks like, quadratic, cubic, square root, which we haven't done very many of, but we will be doing more, and exponential, which you may not have. Notice where the x is in this case. X is actually the exponent, and see where this graph goes. Okay? Now, I want to show you this in terms of domain and range. When you see D and R, domain and range. So when I look at this, the domain, or all my possible x values, see how I have an arrow here? I could pick any number I want for x. There's no restrictions. So my domain is all real numbers. Any real number could be x. And you notice there's also no restrictions on y. That arrow, or that line, could go infinitely in either direction and be any y value. So the range is also all real numbers. This is what we choose when there are no restrictions on our domain or range. But look at this one. My domain, once again, I could put any number I want in for x. I could put positives, negatives, fractions, it doesn't matter. But because I'm squaring the number, my range will always be greater than or equal to 0. Because even if I put a negative number in here, a negative number squared gives me a positive out for my answer. So the range, as you can see from the graph, is restricted. It's not going to be down here unless I do something else to that equation. So y is greater than or equal to 0. Now I look at this one. The domain, I can put any number in for x, all real numbers. And the range, all real numbers. I can get any number back out. Square root's a little bit different. See where it's located? It's just up here in the first quadrant. That means my domain has to be greater than or equal to 0. Because we're not dealing with imaginary numbers, we can only have a positive number or 0 inside that radical sign. So that restricts my domain to being greater than or equal to 0. Oops, this should be an x. My apologies. Perfect. Okay. My range, the same thing. When I find out what the square root of that number is, it's going to be a positive number. So it has to be greater than or equal to 0, both of them. And you can see that because it's located only here in the first quadrant where everything's positive. These other ones move around to different quadrants. In this one, everything's positive. The last one, the exponential, is going to go up in a sharp curve like that. It approaches but doesn't quite touch 0. That's a little off there, but it'll approach but never quite touch 0. But I can put in any number I want for x. I could put in a negative number, I could put a positive number, I could put a big number, a small number. X can be any number, so I write all real numbers for its domain. However, the range is restricted because no matter how small I make this, it will never make this into a negative number. Okay? This number will stay, and so my range of this one is got to be greater than 0. So this foundation needs to be, and I think you have it already in your notes, you can just add in the parts that you don't have in your notes. I think exponential functions is not there. We'll be going to talk about this in more detail tomorrow. But I want you now to identify the function family and then the domain and the range of each one of these functions. So please take a second, put this on pause, copy them down, and then I'll go over the first one with you and you'll bring the others to class tomorrow. Okay, the first one looks to me like it's y equals x squared, right? Clearly, I've turned it upside down and made it negative, and I've moved it up a little bit, but this is the function family that it belongs to, the quadratics. The domain, I can put any number I want in for x. There's no restrictions. So I'm going to write all real numbers. But the range is limited. And the range is limited to, it's got to be, what is that, 1, 2, 3. Y is going to be less than or equal to 3. You see why that would be so? I just count it up and see every single value for y is going down below the 3. So that's where I get that from. So check these. Make sure that you have those completed before you bring those to class tomorrow. And please write down the questions that you might have about functions, about domain and range, and we'll talk about that at the beginning of class.